Bismillahirrahmanirrahim. So, connecting with the previous lecture, in that lecture we have studied different forecasting models. We have studied linear regression equation, how you will run linear regression equation, how you will construct a trend line. So, today I'm just going to discuss some more indicators, some more measure in order to check the forecasting, in order to check the relationship between the different variable data. For example, if you have two variables, then how they reacting with one another, how it behaving. So you heard the name correlation, covariance, and coefficient of determination. So in today's lecture, I'm just going to discuss these, that what is correlation, what is covariance, and what is coefficient of determination. So I will also use Excel to use some specific data in order to calculate correlation, covariance, and coefficient of determination. Basically, these are the indicators which will tell us about a specific data set, which will tell us more about the behavior of the data. So, before going to that, you need to understand correlation. What is correlation? Sometimes we use co. Co means the contribution between two things, the relationship between two, correlation, which measure the strength of relationship between the dependent and independent variable. So we will check the relationship between two variables. One will be dependent and one will be independent. If the number of variables are more than two, then in that case we will calculate coefficient of determination, and from coefficient of determination we can easily get correlation. But the formulation for two variables, in which one will be dependent and one independent, the formulation is different for more than two variables. Once a model has been developed and tested, the effectiveness of the model need to be determined. So correlation is used to determine how strong the relationship between the dependent and independent variable. So in my previous lecture, in the linear regression, we have already discussed different examples. That for example, the sale of umbrella will be going up when the rainy season going up. When the rainy season duration is going up, then the sale of umbrellas will also be going up. So now the season, the specific atmosphere, the specific weather condition depending on the umbrella sale. In another example, I already discussed that if a person smoking too much cigarette, then his lung or her lung efficiency will be reduced. So in this case, now one is going up, the other is going down. So once a model has been developed and tested, the effectiveness of the model, but normally when we have a data set, we will not be able to determine that what kind of behavior of one dependent variable and how it impact the other variable. For example, when a person monthly income increase, then definitely his consumption, his utilization of income will also be going up. So correlation is used to determine how strong the relationship between the dependent and independent variable are. Normally, we use this mathematical formulation, and you already know that if you already understand the correlation, the linear regression example, so the construction of this formulation is not so difficult. N represent basically the sample size, number of periods, the previous period which you want to take. X represent the independent variable and Y represent the dependent variable. So summation xy, you need to multiply x with y, and then you need to sum, and then you need to multiply with n. So you will get this term minus summation x, sum of all the x value, summation of y, sum of all y value, divided with the square root of n summation x square. You need to take the square of the independent variable each unit, and then you need to sum it, and then you need to multiply with the number of periods, the past period for which you want to use, which you want to utilize, minus summation x whole square, then in another bracket n summation y square minus summation y square. So at this way you will be able to calculate the relationship between dependent and independent variable. It will show you that what kind of behavior is it. Both variable, both dependent and independent variable moving in the same direction, they behaving same. When one increase, the other is also increase, or they have no dependency on one another. Mean if something happen, for example, the hair color of a specific student and the age of a specific student, or the hair color of a specific student and the height of a specific student. So now these two variables, one is the hair color and the other is the height. So height and hair color have no relationship with one another. So maybe in your data, maybe both variables have no dependency on one another, or maybe it will be a situation that one is going up, the other is also going up, just like in the ice cream example. When the sale is going up, when the temperature is going up, the sale of ice cream is also going up. Or in the other case, in the smoking cigarette case, when a person smoking too much cigarette, his lung efficiency will be reduced. So one is going up, the other is going down. So now from a data set, we can easily check if the value of the R is equal to plus. If it is in the plus, then it will be going in the positive direction. Both are going in the same direction. So I will show you that this is also called perfect positive correlation, and you can see that when X is going up, Y is also going up. When temperature is going up, for example, this X represents the temperature, then the sale of ice cream is also going up. So when the temperature centigrade at this place, the sale is at this place. But at this point, when it's going high, then the sale of ice cream is also going up. This is called perfect positive correlation. And normally the value of R, which lie between plus 1 and minus 1, you need to remember the correlation value will always be lying between plus 1 and minus 1. So in this case, it will be positive correlation if the value is positive. The another scenario, this is also a positive correlation, but when it's plus 1, it's greater than 1, okay? Then in that case, it's called positive correlation. This is also a positive correlation, but this is a scatter plot. In this scatter plot, we want to construct a linear trend line, and the R value will be lie between 0 and 1. It will be less than 1, but it will be greater than 0. So this will also be a positive correlation. The another case is no correlation. So I already mentioned an example, the height of a student and the hair color of a student. So height and hair color have no relationship. In that case, the R value will be equal to 0. So for example, if you have collected some specific data, and if you calculate correlation while using that formula, or if you use some Excel, because in Excel we can directly calculate this value. So in that case, R value will be equal to 0. Another case is perfect negative correlation. Perfect negative correlation value will be equal to minus 1. So that is why I told you before that the correlation value will always be between plus 1 and minus 1. When it is plus 1, it will be considered as a positive correlation. When it is minus 1, it will be considered as a perfect negative correlation. Perfect negative correlation, for example, if a boy smoked too much cigarettes, so the number of cigarettes is going up, but on the other side, when it's going up, this is going down. The lungs efficiency, for example, Y represent the lung efficiency. It's going down. The lung efficiency will be going down. So one is going up, the other is going down. So it be having like this one. But in the other opposite case, it's going up. When one is going up, then the other is also going up. When one is going down in the perfect negative correlation, the other is going up. So on the basis of these, I will show you in a simple example that how you will calculate correlation while using Excel, how you will calculate covariance while using Excel in an Excel example. But before going to that, you also need to calculate coefficient of determination. Coefficient of determination normally we denote with R square. Measure the percentage in Y predicted by the change in X. So R square, R is correlation. When you take the square of R, you will get coefficient of determination. So in the hypothesis testing, we have already studied in business statistics that when we calculate R square, it shows what it shows. Basically, this is a measure which shows the percent of change in Y predicted by the change in X. So Y is a dependent variable and X is an independent variable. Y predicted by the change in X, that how much change occur in Y due to X. Value range from 0 to 1. So once again, because the correlation value between 1 and minus 1. So minus 1 is not here because minus 1 when you take the square, if R is equal to minus 1, when you take the square of minus 1, it will become positive. So that is why the coefficient of determination value lies between 0 to 1. A high value of R square, say 0.80. So mean if a value is 0.80, for example, if some specific data set, our coefficient of determination value is 0.80, which will indicate that the independent variable is a good predictor, that independent variable X is a good predictor of values of the dependent variable. So in that case, we will check that, we will measure that our independent variable, for example, the time period, is a good predictor of values of the dependent variable, that the sale of ice cream is a good the time is a good predictor for the sale of ice cream, which is dependent variable, the sale of ice cream in our example. A low value, say 0.25 or less, would indicate a poor predictor. For example, because the value of coefficient of determination will be lie between 0 to 1. So if the value is lower, it's near to 0, it will show that the independent variable is a poor predictor. So in this, we show that independent variable is a good predictor of values. But in this, if it is approaching towards 0, we will say that it would indicate a poor predictor. A value between 0.25 and 0.80 indicate a moderate predictor. So it depends on you. If the value from a specific data set is lying between, let's suppose 0.50, then we will consider it as moderate predictor. But if the value is approaching to 1, we will say that it is a good predictor. But if it is less than 0.25, it's approaching towards 0, we will consider that it's a poor predictor. So now I'm just going to show you that how you will use Excel in order to calculate correlation, covariance, coefficient of determination in a simple example, in a simple Excel example. So in this example, we have two type of data: correlation between mileage and price for 19 Japanese cars. This is a data set for the 19 Japanese cars, in which one variable showing the mileage and the other variable showing the price. Okay, so this is my mileage and this is my price. Now we want to check the behavior of these two variables. In these two variables, this is, let's suppose this price is independent variable and this is a dependent variable. So now we want to calculate correlation, that what kind of relationship between. So we have already studied that correlation values will be lying between +1 and -1. If it is +1, then it will be a perfect positive correlation. If it is -1, it will be perfect negative correlation. If the value is between 0 and 1, we will consider it as a positive correlation. But if the value is lying between 0 and -1, then we will consider it as a negative correlation. So from this we can also calculate mean. So how you will calculate mean? So the mean formula so this is the mean for, if I click it, the mean of the mileage, this is the mean of the mileage. So it is very easy. Average, you need to calculate the mean of this. Okay, so enter, you will get the mean of the mileage for the another variable, average. So the average formula is the mean of the price. So this is my average price. And similarly, standard deviation, you can also calculate the square root of f of t. So we can easily calculate while using the formula which I already mentioned to you. Or if you want to use another formula which is equal to standard deviation, this one for, standard deviation for the mileage. So this is the standard deviation for the mileage and is equal to standard deviation sample, because this is sample data, of the price. So you can easily calculate the standard deviation. For correlation is equal to, so when you write is equal to correlation, automatically it will be appear correlation. So in correlation, it's showing you to array 1 and array 2. So this is my array 1 mean, because we want to calculate relationship between one dependent variable and another independent variable. So let's suppose we not know which one is dependent and which one is independent, comma. So you choose these two array and this one and just put enter. So now you can see, so this is the formula, or you can use the other formula which I already show you in the slides. So you can also use that formula, but this one is the easiest one. So the correlation is minus 0.72. So what it basically show, minus 0.72 minus 0.72 is approaching to -1. So there is some strong negative correlation exists. This is a negative correlation, but this is not -1. It's near to -0.1. So we can say this is a negative correlation, but it is not a perfect negative correlation. You can also utilize, just like in the covariance, we use two different formulas, but you can also, if you want to use is equal to covariance, so you can also use covariance. You need to click this covariance of sample. Okay, now you need to select this data, these two variable data, and then you need to choose this, the mileage data, and then comma the price data, because these are two different variable, and then enter. So you will get this covariance. So you can see, you can calculate covariance because S show the sample data. If you have population data, a big data set, then it will be covariance. Automatically Excel will tell you that you want to use covariance, you want to calculate covariance for sample data, or you want to calculate covariance for population data. So we can easily calculate this. So there are also some other formulation. If you want to use x minus m bar, m minus m bar. So basically this is x and this is, let's suppose, y. So we will denote with m and this with p. So m minus m bar mean is equal to m, this value, minus the mean of this, the mean of the mileage. So this is the mean of the mileage. Once again, you need to put a dollar sign at this place and at this place, because we want to count, we want to keep this value as a constant. We want to subtract mean from each value of m. So you need to drag it down. When you drag it down, you will calculate. Similarly, in the p minus p bar, we want to check, we want to subtract the price, each value of price, we want to subtract mean. So the mean of the price is this one. Once again, you need to put dollar sign before and after the cell. The D is the cell. So you need to put this, because we want to keep this mean constant. We want to subtract each value of price through the mean. So we just subtract. If you click this randomly, it's showing that the price for this period, subtract 13.93. 13.93 is the mean of this price data. So in this way, then in the next column, you will calculate, because we want to take the square. So you need to take the square of this, and then you need to drag it down. When you drag it down, you will calculate this. Similarly, is equal to, you need to take this, and you need to take the square of this, and you need to drag it down. When you drag it down, you will calculate this in the next step, because you can use this formula for the covariance. So is equal to this multiplied by this. Okay, so you need to drag it down, you need to drag it down. So if you want to use this formula for covariance, which is very easy, so if you click this, this is basically the sum of what? The sum of x minus mean multiplied by y minus y mean. So m is our mileage data, minus subtract mean of the mileage data, p is the price, minus subtract the price mean. So when you multiply this, when you sum this, so this formula you can also calculate is equal to this value divided by 18, because we have 18. Okay, covariance. And if you want to calculate the coefficient of determination, how you will calculate? It will be equal to this value taking the square. So our coefficient of determination, which is the square of correlation, which is 0.52. So as I already mentioned, that if the value approaching to +1, it means that it is a good predictor, that the independent variable is a good predictor. But if it is approaching to 0, it means this is a poor. But in this case, it is a mediate. We can say this as a mediate predictor. So in this example, I just try to show you that how you will use Excel for to calculate correlation, covariance, coefficient of determination, how you will calculate mean, how you will calculate covariance of a sample data. So thank you so much.